Section 501.10b3 of the National Electrical Code, or NEC, provides requirements for the encasement of non-metallic conduit in hazardous areas. Non-metallic conduit or tubing shall be encased in not less than 50 mm, which is 2 inches, of concrete within the hazardous classified area. This requirement applies to non-metallic conduit or tubing located within the hazardous area. The encasement must extend at least 50 mm, or 2 inches, beyond the boundary of the hazardous area. Therefore, the concrete encasement is not required to be extended into the non-hazardous area from the hazardous area. Whether the under-slab area is considered hazardous depends on the specific conditions and the classification of the hazardous area. In general, the hazardous area classification is based on the presence of flammable or combustible materials, gases, or vapors. If the under-slab area does not contain any flammable or combustible materials, gases, or vapors, then it would not be considered hazardous. However, if the under-slab area is exposed to flammable or combustible materials, gases, or vapors from the hazardous area above, it may be considered hazardous. In these cases, the concrete encasement of the polyvinyl chloride, or PVC, would need to be extended below the slab to protect it from any potential hazards. The NEC provides guidelines for electrical installations in hazardous locations to minimize the risk of fire or explosion. These locations are classified based on the type of hazardous material present, such as flammable gases, vapors, or dust, and the likelihood of their presence in ignitable concentrations. The classification determines the types of equipment and wiring methods permitted in the area. Non-metallic conduit is often used in underground installations for its resistance to corrosion and ease of installation. However, in hazardous locations, it needs to be protected from potential damage and the propagation of fire. Concrete encasement provides this protection by creating a physical barrier around the conduit. The minimum thickness of the concrete encasement, as specified in NEC Section 501.10b3, is 50 mm, or 2 inches. This thickness is deemed sufficient to prevent the spread of fire and to protect the conduit from mechanical damage. The encasement must extend beyond the boundary of the hazardous area to ensure that the conduit is adequately protected even if the hazardous atmosphere extends slightly beyond the designated area. The determination of whether an under-slab area is considered hazardous requires a careful assessment of the specific conditions. Firstly, the presence of flammable or combustible materials, gases, or vapors needs to be evaluated. Secondly, the potential for these materials to migrate into the under-slab area from the hazardous area above should be considered. Factors such as ventilation, sealing, and the integrity of the slab can influence the migration of hazardous materials. If the under-slab area is determined to be hazardous, the concrete encasement of the PVC conduit must be extended below the slab. The extent of the extension should be sufficient to protect the conduit from any potential hazards. In some cases, it may be necessary to extend the encasement to a point where the area is no longer considered hazardous. The NEC provides detailed requirements for electrical installations in hazardous locations. It is essential to consult the code and other relevant standards to ensure that all installations comply with the applicable requirements. Proper design, installation, and maintenance of electrical systems in hazardous locations are crucial for preventing fires and explosions and protecting people and property. The NEC is updated regularly to reflect the latest technological advancements and safety practices. It is important to stay informed about the latest changes to the code and to ensure that all electrical work is performed by qualified professionals. The specific requirements for electrical installations in hazardous locations can vary depending on the type of hazardous material present, the classification of the area, and other factors. It is always best to consult with a qualified electrical engineer or inspector to determine the appropriate requirements for a particular installation. The use of non-metallic conduit in hazardous locations is subject to certain restrictions. Non-metallic conduit is not permitted in certain types of hazardous locations, such as those where flammable liquids or gases are present in large quantities. In these locations, metallic conduit is typically required. The NEC provides detailed information about the types of conduit permitted in different hazardous locations. It is important to carefully review these requirements before selecting the type of conduit to use. The concrete encasement of non-metallic conduit in hazardous locations must be properly installed to ensure that it provides adequate protection. The concrete must be of sufficient strength and thickness, and it must be properly cured. The encasement must also be free of cracks and other defects. Any defects in the encasement can compromise its ability to protect the conduit. Regular inspections of electrical installations in hazardous locations are essential for identifying potential problems and ensuring that the installations continue to comply with the applicable requirements. Inspections should be performed by qualified professionals who are familiar with the NEC and other relevant standards. Any problems identified during inspection should be corrected promptly to prevent fires and explosions. The NEC is a comprehensive code that covers a wide range of electrical topics. It is essential for anyone involved in the design, installation, or maintenance of electrical systems to be familiar with the code. The NEC is available for purchase from the National Fire Protection Association, or NFPA. There are also many resources available online that can help people understand the NEC. The NEC is a valuable tool for ensuring the safety of electrical installations. It is important to use the code properly and to follow all of its requirements. Failure to comply with the NEC can result in fires, explosions, and other hazards. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or inspector before performing any electrical work. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Always disconnect power before working on electrical equipment, and use appropriate personal protective equipment. The NEC is a living document that is constantly being updated. It is important to stay informed about the latest changes to the code and to ensure that all electrical work is performed in accordance with the current requirements. The NEC is a valuable resource for ensuring the safety of electrical installations in hazardous locations. By following the requirements of the code, you can help to prevent fires, explosions, and other hazards. The NEC is not the only standard that applies to electrical installations in hazardous locations. Other standards, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the International Electrotechnical Commission, or IEC, may also be relevant. It is important to be familiar with all of the applicable standards before performing any electrical work in a hazardous location. The selection of electrical equipment for use in hazardous locations is critical. The equipment must be specifically designed and certified for use in the particular type of hazardous location. The equipment must also be properly installed and maintained. Failure to use the correct equipment or to install it properly can result in a fire or explosion. The NEC provides detailed requirements for the selection and installation of electrical equipment in hazardous locations. It is important to carefully review these requirements before selecting and installing any equipment. The use of intrinsically safe circuits is one method of protecting electrical equipment in hazardous locations. Intrinsically safe circuits are designed to limit the amount of energy that can be released in the event of a fault. This reduces the risk of ignition of flammable materials. The NEC provides detailed requirements for the design and installation of intrinsically safe circuits. Another method of protecting electrical equipment in hazardous locations is to use explosion-proof enclosures. Explosion-proof enclosures are designed to contain any explosion that may occur inside the enclosure. This prevents the explosion from spreading to the surrounding environment. The NEC provides detailed requirements for the design and installation of explosion-proof enclosures. The NEC also addresses the issue of bonding and grounding in hazardous locations. Bonding and grounding are used to ensure that all metallic parts of an electrical system are at the same potential. This reduces the risk of electric shock and the ignition of flammable materials. The NEC provides detailed requirements for bonding and grounding in hazardous locations. The NEC is a complex and comprehensive code. It is important to seek professional assistance when designing, installing, or maintaining electrical systems in hazardous locations. A qualified electrical engineer or inspector can help you to ensure that the installation complies with all of the applicable requirements. The NEC is a valuable tool for ensuring the safety of electrical installations in hazardous locations. By following the requirements of the code, you can help to prevent fires, explosions, and other hazards. Understanding the specific classification of a hazardous location is paramount. The NEC defines different classes, divisions, and zones to categorize hazardous areas based on the type of hazardous material present and the likelihood of its presence. Each classification dictates specific requirements for electrical equipment and wiring methods. For example, Class I locations involve flammable gases or vapors, Class Roman II locations involve combustible dust, and Class Roman III locations involve ignitable fibers or flines. Within each class, divisions or zones further refine the classification based on the probability of the hazardous material being present under normal or abnormal conditions. Understanding these classifications is crucial for selecting the appropriate electrical equipment and ensuring a safe installation. Proper ventilation is often a key factor in mitigating hazardous conditions. By providing adequate ventilation, the concentration of flammable gases, vapors, or dust can be reduced to a safe level. The NEC recognizes the role of ventilation in reducing the extent of hazardous areas. In some cases, properly designed ventilation systems can allow for the use of less stringent electrical equipment and wiring methods. However, it is important to carefully evaluate the effectiveness of the ventilation system and to ensure that it is properly maintained. Sealing is another important technique for preventing the spread of flammable gases, vapors, or dusts. Sealing fittings are used to create a barrier that prevents these materials from migrating from one area to another. The NEC provides detailed requirements for the use of sealing fittings in hazardous locations. Sealing fittings must be properly installed and maintained to ensure their effectiveness. Regular inspections of electrical installations in hazardous locations are essential for identifying potential problems and ensuring that the installations continue to comply with the applicable requirements. Inspections should be performed by qualified professionals who are familiar with the NEC and other relevant standards. Any problems identified during inspections should be corrected promptly to prevent fires and explosions. Documentation is a critical aspect of electrical installations in hazardous locations. Detailed drawings, specifications, and other documentation should be maintained to provide a record of the installation. This documentation should include information about the classification of the hazardous area, the types of electrical equipment used, and the wiring methods employed. Proper documentation can facilitate future inspections and maintenance and can help to ensure that the installation remains safe over time. Training is essential for personnel who work in or around hazardous locations. Personnel should be trained to recognize the hazards present, to understand the safety procedures, and to use the appropriate personal protective equipment. Training should be provided on a regular basis to ensure that personnel remain knowledgeable and competent. Emergency preparedness is another important consideration in hazardous locations. Emergency plans should be developed to address potential incidents such as fires, explosions, and releases of hazardous materials. These plans should include procedures for evacuation, first aid, and communication. Emergency drills should be conducted regularly to ensure that personnel are familiar with the plans. The NEC is a valuable resource for ensuring the safety of electrical installations in hazardous locations. However, it is important to remember that the NEC is not a substitute for sound engineering judgment. Electrical installations in hazardous locations should be designed and installed by qualified professionals who have a thorough understanding of the hazards present and the applicable requirements. By combining the knowledge and experience of qualified professionals with the requirements of the NEC, it is possible to create safe and reliable electrical installations in hazardous locations.